Hello everyone, this video will teach you how to use dummy signals to visualize the value of state variables used in a web program. In an earlier video, I showed you how to create a simple intersection that can be controlled using a web file written by Professor Firth called 2_phases17. Here is the web file. For this demonstration, we'll use a dummy signal to visualize the variable hasCall. Now I'm going to find our variable hasCall. Here is the first one, we define the variable, and the second one is in subroutine locking call. It becomes 1, get a value of 1 when the detector be occupied more than our call delay time, which we define it to. The next place is here in subroutine imminent to rest. It gets a 0 value when our green light starts and goes to early green. We will also use a dummy signal to visualize the variable extension green. I'm going to search it, ext green. Here is the first extension green. As you can see in the code, it should get a value of 1 when the phase leaves early green, which happens after the minimum green period, which is 10 seconds. And it should get a value of 0 when the phase either has a long gap or reaches its maximum green. Here is the network we created in the previous video. It has one junction which has two signal groups. We are going to visualize variables only for the northbound approach, which is signal group 2. To visualize hasCall for signal group 2, I will create a new link and put a signal head on it. It's signal head 3, and I created two more signal groups, and I connected to signal group 3. And to visualize extension green for signal group 2, I also create another new link, a new signal group head. It is called, and I connect it to signal group 4. Now in the web code, to visualize hasCall 2, I will add the following lines. I add if hasCall 2, then signal group 3 goes green, and otherwise it goes red. Remember that hasCall can only be 0 or 1. This code says that when it's 1 or true, make the dummy signal green, and when it's 0 or false, make the dummy signal red. And similarly, add the code here so that when extension green 2 equals 1, dummy signal 4 will be green, and when it's 0, the dummy signal will be red. And also, I should modify our PUA file. In our PUA file, here we have signal groups, and we should add the number of signal group as much as we need and we have in our network. Because we have now 4 signal group, I will add 2 more signal groups, and I will name it 3 and 4. We don't have to do anything with stages part. And I will save it. Now I will run the program. I paused it. You can see both dummy signals are red, which means that for the northbound approach, Haskell is 0 and so is extension green. Now watch the dummy signal for Haskell. I will run it step by step. The car enters to the detector at time 12.1 and we can see at 14.2 it goes green after 2 seconds of call delay. Now I run the simulation and now it goes red after our real signal goes green. And also our dummy signal for extension green is red because it didn't reach the extension green time. Again, the second cycle starts and at time 61.2 our extension green dummy signal works.